Okay. Welcome everyone to Green and Healthy Community. My name is Heather Marquetta, Adult Services Director at the Richard Salter Storrs Library in Longmeadow, Massachusetts. And I would like to thank all of our presenters for taking time out of their busy schedules to be here today. During this program, each speaker will have 15 minutes to present and will receive a tonal warning at the 14-minute mark. So we are going to begin today with Professor Rahman AZARI, architect, associate professor, and founding director of the Resource and Energy Efficiency RE2 Lab at Penn State Department of Architecture. Dr. AZARI is also co-founder faculty of Penn State Institutes of Energy and the Environment. His research focuses on life cycle environmental impacts of built environments, innovative construction materials for energy production and carbon sequestration, building and urban energy and carbon efficiency, and data-driven models for urban sustainability. He was a recipient of the American Institute of Architects Upjohn Research Grant in 2018 and 2019 for his collaborative project on artificial leaf-based facade cladding systems for energy generation and carbon sequestration. Dr. AZARI has also sponsored winning entries to ACSA AIA COAT, Top 10 competitions in 2016 and 2017. In 2019, he was recognized as a researcher to know by the Illinois Science and Technology Coalition. In 2018, he co-edited the Energy and Buildings special issue on embodied energy and carbon efficiency. Dr. AZARI's research has been widely published in various journal venues such as Energy and Buildings, Building and Environment, and Applied Energy. With a background in architecture, he holds a PhD in built environment from University of Washington in Seattle. Aside from teaching, he has extensive experience in the field of civil construction management, focusing on design, estimation, and scheduling of pre-engineered steel buildings. Welcome, Dr. AZARI. Please begin.
Hello, everyone, and thank you very much for the kind introduction. I am going to share my screen and present from there. Are you able to see my screen?
Yes.
Perfect.
All right, may I say something? May I ask everybody to mute themselves and even take the video off so we don't have any interference? Thank you.
Good morning, everyone. And it's a pleasure to be here and presenting for you. There is a great book called Ecological Intelligence by renowned psychologist Daniel Goleman, in which he argues that in 21st century that we are experiencing a range of climate change issues, global warming, extreme events related to global warming, and other natural disasters. We need to develop a new kind of intelligence through which we would be able to understand and estimate the environmental impacts of our decisions, from design and construction of the buildings to transportation to purchasing of products and so forth. And one evidence to climate change and one evidence to the need for developing of this ecological intelligence is the fact that if you look at the historical data on how carbon dioxide concentration has increased in the atmosphere, we see that most recent data suggests that the level of CO2 concentration has reached an unprecedented 416 particles per million, which is well above the maximum and the average that has been previously experienced. So with this level of CO2 concentration and the fact that it had led currently to global warming, the data suggests that if we continue the current policies, we would be achieving a 2.8 to 3.2 degrees Celsius of increased global warming. If we try to limit significantly CO2 emissions, we might be able to achieve the 1.5 degrees Celsius as the maximum to increase global warming. But if you look at the data published by Energy and Information Administration, And if we compare the current levels of energy consumption as a contributor to global greenhouse gas emissions, if we compared current data with 1970s and early 1980s, 1970s is important because we experienced two oil crises, and also it was the decade that we started to develop energy efficiency codes in building and transportation sector. In 1975, we have the first energy code by American Society of Heating, Refrigeration, and Air Conditioning Engineers, ASHRAE. And in 1979, the second oil crisis of the decade happened. So that decade was especially important in raising awareness about the need to make the buildings more energy efficient. And if we compare again as the current data regarding the energy consumption of the built environments with 1980s, we see that since then we significantly have increased the energy consumption that in the building sector, despite significant also improvements in the codes. We now have much more stringent codes in terms of the energy efficiency. We now have requirements to use insulation in building skin, but still the energy performance of the building has continued to increase. And if we look at the data to see what causes this increased energy consumption, probably it could be reduced to three factors. One being that we have an increased US population since 1980s and 1970s. We have an increased number of households, indeed 62% more households we have now currently as compared with 1980. And we also tend to live in bigger buildings and bigger houses. So the currently the square footage of new housing in the US is 47% bigger than the square footage of new housing in 1980s. So these three factors help explain the increased energy consumption over the decades. We also know that currently 39% of the energy that is used in the US annually goes to buildings, and that is for operation of the buildings. In other words, we use that energy to heat the buildings, to cool the buildings, and to illuminate the building around the equipment in them. 18% of that energy goes to commercial sector and 21% goes to in residential sector. But as you see in these diagrams, most of this energy is used for space heating and water heating and space cooling. In other words, we spend significant amount of that energy just to heat and cool and illuminate the buildings, which we could well control using the strategies that we have in design and construction. We have learned that some of the good strategies to control the heat flow in buildings and reduce the energy consumption of the building is about using more insulation in building skin, using shading systems, using photovoltaic panels. All of that reduce the energy consumption of the building. But one unintended consequence of these energy efficiency strategies has been the fact that all of these strategies mean that we need to use more materials. More materials oftentimes translates to more energy that is used in manufacturing facilities to produce those materials. In other words, that translates into more embodied energy. Embodied energy is the energy that it takes to build the buildings, and embodied carbon, or the carbon associated with embodied energy. So we have been able to save the operational energy and operational carbon, but at the expense of higher embodied energy and higher embodied carbon. In the end, we still have been able to save a lot of energy, but it would be good to consider the embodied carbon early in the process of the construction and design of the buildings. So in 2021, now the net zero energy buildings and net zero operational carbon buildings are completely a possibility. So it's not a research problem. It's more of a technology problem, a financial problem, and cultural problem that we have to convince people to build more net zero energy buildings. Net zero energy buildings are buildings that are able to produce as much energy as they consume on a net annual basis. So with the possibility of net zero energy buildings now, The next goal of the building community is to build the buildings that are also net zero embodied carbon. So a net zero embodied carbon basically means that in buildings, we have to use materials that are low embodied carbon. As you know, the cement and concrete, for example, because of their vast quantities that are used in building construction, they result in significant global warming potentials. And now there are attempts to find substitutes and find better the cements that have lower global warming potential. Even in the case of insulation, one type of insulation that are widely used in buildings is called XPS insulation that uses a content in it that is called hydrofluorocarbon, HFC. And HFC was used in insulation as a replacement for CFC, chlorofluorocarbon, which in several decades ago, through Montreal Protocol, we learned that we have to substitute CFCs because of their high ozone depletion. So we used HFC or hydrofluorocarbon to substitute CFC, and HFC has low ozone or zero ozone depletion potential, but has extremely high global warming potential. And now the US Congress has mandated replacement of HFC with new materials that have both zero ozone depletion potential and low global warming potential. And one replacement is HFO or hydrofluoroolefins. So there are significant attempts in building industry to reduce the embodied carbon of the buildings, in addition to parallel efforts to reduce the operational energy consumption. Embodied energy and embodied carbon is about materials. What are the materials that we use, where we get those materials from, and what would be potential replacement for those materials in order to reduce their global warming potential. Embodied carbon, as I mentioned, looks at the entire life cycle of the building, and it's about energy, and embodied carbon is about the carbon that is emitted to extract material from their sources, manufacture them in their manufacturing facilities, and construct, maintain, and demolish the buildings. And also this transportation between these processes are taken into account in embodied carbon estimation. So we have to first learn to estimate embodied carbon, and we have to raise awareness about the needs for the building owners and the architects to be aware of the embodied carbon of their buildings, and then find ways to reduce that globally and nationally. These are some examples of the work that students in my classes use embodied carbon and operational energy simulations in order to estimate embodied carbon and find what contributes indeed to the high embodied carbon of the building that is designed. We know that globally 30% of the energy consumption goes into building operation, and 6% goes to embodied energy. In terms of the CO2, it is 28% contribution of buildings to global CO2 emissions and 11% contribution of embodied carbon. But as we build more energy efficient buildings, the share of the red in this pie chart, or the share of operational energy and carbon, becomes smaller, and the share of embodied carbon and embodied energy becomes larger, and therefore there is an urgency and need to decrease the embodied energy and carbon of the buildings. So with that, I stop and I transfer to the next presenter. Thank you very much for listening to me.
Thank you, Dr. AZARI. Our next speaker, if he's ready, is Professor Adrian Altenberger, head of the Institute of Building Technology and Energy, Lucerne University School of Engineering and Architecture. Professor Altenberger holds a bachelor's degree in Building Technology Engineering and a master's degree in Architecture, as well as a master's degree in Business Administration. From 1989 to 1999, he joined Electrowatt Engineering Limited in Zurich, Switzerland, and Bangkok, Thailand, as a project engineer and head of the department HVAC. From 1999 to 2015, he was partner COO and member of the Board of Directors at Amstein Walter Limited, an engineering and consulting company with 800 employees in Zurich. Since 2009, he has been a member of the Board of Directors and Vice President of the Swiss Society of Engineers and Architects, and since 2010, a member of the Board of Directors and Vice President of the Swiss Association for Standardization. In 2013, he joined SwissNext Boston for a sabbatical and was a guest lecturer at Harvard University Graduate School of Design. It was during this time and related to the Walk Door exhibition in 2014 that Dr. Altenberger helped to develop the idea for the Swiss-US Energy Innovation Days Forum. Welcome, Dr. Altenberger. Please begin.
Thank you, Heather. And first of all, sorry for my late appearance. Greetings here from Switzerland. It's already quite evening here, late autumn in Switzerland, quite cold. I hope you have still this Indian summer on the East Coast. And thank you for the introduction, Heather. So I share my, my screen. I hope you can see my presentation. And my aspect for today is low exergy concepts for buildings, which is mainly related to buildings as and buildings in a system. As mentioned, I am the head of the Institute of Building Technology and Energy at Lucerne University. And within our program, this low exergy concept is a main task to go into the project modules with our students. And I hope that it's time to expect more than only energy efficiency. It should be also exergy efficiency. But let me bring up the different points for today. I will introduce some problems, but also the no problems and trends shortly. Then I go over shortly to thermodynamics aspects and exergy. And then I will mainly show you some examples which have already been realized in Switzerland with these low exergy concepts and solutions. And then finally, I end up with the conclusion. So now, as everywhere in the world, but also in Switzerland, as you see here on this graph, we have increasing ambient temperatures indicated here since 1870 until the late 2010s. And it's obvious that also in Switzerland with the Alps, this increasing temperature will demand for a transformation of the building stock, which is mainly based on like 70 to 80% still fossil-based heating. As you maybe know, in Switzerland, we have a comfortable situation about electricity generating, which is about 60% from hydropower, and the rest is mainly nuclear power. But we have decided politically to shut down the nuclear power by 2035. So not too much time for the transformation and increasing of renewables in the energy supply side. So the no problem is this graphic, as you see, related to one of the renewable sources, solar power, solar energy. Globally, we need about 16 terawatt hours per year of energy, and there is an input of factor 10,000 more, like 174,000 terawatt hours. For sure, it's a big part is reflected, a big part is absorbed. There is still about a factor 200 which could be generating electricity by PV with an efficiency of 12%, which is now partly higher already, but it's a factor of 200 between demand and supply potential only related to PV. So we don't really have an energy problem. We have a problem with our CO2 emissions, for sure. Decarbonization is the way we have to go, and we have an exergy problem anyway. So the problem we have, especially also in Switzerland, as you maybe know, we have a relatively old building stock in Switzerland. These old towns also, because we haven't haven't been involved in the Second World War, for example. So they're really old towns, which are originally related to about 200, 300. I myself live in the eastern part of Switzerland in a building which is 350 years old. I have a neighbor with a wooden building about 500 years old, nicely renovated anyway, but an old building stock. So the materials in the buildings related to embodied CO2 is relatively small in these old buildings because related to the life cycle they already had behind them. So the quick step to transformation for the existing building stock is the increasing of efficiency by optimization of the existing systems or isolation. Then the classic step is to reduce the energy demand and the CO2 emissions. And the holistic step is an integration into area energy grids, like integrating heat sinks and heat sources at the same time, and also seasonal storage. I will show you then the examples which are related to this holistic step. No problem for new buildings. Practically all of the new buildings in Switzerland are already net zero related. Here you see a picture of a residential building close to Zurich, town of Zurich, which has an integrated PV system in the facade. So also from the architectural point of view, quite nice solution. So you don't see obviously these technical stuff. It's an integrated solution, which has been realized in this case here about 5 years ago, and is running. And all over Switzerland, there is more and more solutions with this integrated facade PV, also beside the rooftop integrated PV upcoming. So the three trends also in Switzerland, like also in the Western Hemisphere, is decarbonization, decentralization of the energy supply systems, and for sure the digitization, which helps to become also some smart grids, let's say, and to have self-learning building automation systems within the new buildings, and to transform also the old buildings in this direction. Now, related to thermodynamics, as you maybe know, exergy is a part of energy and exergy. It's related to the second law of thermodynamics. As you see in this graph, E is referred to as exergy and B as energy, and this quite simple law of thermodynamics can be used. It's described by Mr. Carnot. It's be used normally also with the heat pump systems. As you see here, the graph for the heat demand, the heating supply related also to this exergy part, which is normally electricity, and then the energy part, the B, which is normally geothermal energy or ambient air for air, water, heat pumps, or lake water, sea water, whatever. Normally the relation of E to B is quite simple and related to only the temperatures of the heat source. And for good efficiencies, we have systems here in Switzerland running with a yearly COP about 8 to 10, which is quite good. The standard is about 3 to 5 in Switzerland, but state-of-the-art systems are running, which I show you after, with about 8 to 10 COPs. So at the Lucerne University, we do have a model related to energy grids for heat sinks and heat sources, so for cooling and heating and storage systems. As you see here, this Notes laboratory, where we can simulate in a not only in a theoretical simulation, but also in a model-based but physical simulation of such energy grids, which we have realized, for example, in one example I will show you after, close to Lucerne University, in an area with about 200,000 square meters residential and 100,000 square meters of office buildings. And important was also after the realization of this area, we had a monitoring which was related to geothermal heat pumps, and it was important to have a stable heat source temperature, geothermal heat source temperature over the years. As you see on the top right graph, the amplitude of the temperature in the underground was between, let's say, close to 20 degrees, and the lowest was close to 7 degrees, so relatively high, because we wanted to run it with pure water and not with glycol integrated. And the COPs, as you see on the graph down on the right, has been about 3.5 in average, and then has been increased by optimization during the running of the systems, and ended up with 4.5 in average. So without any additional investment, but with optimization of the parameters on the temperature side and on the pump systems, the increase of the COPs were quite significant. So the system, as shown here schematically, is defined like you see it here on the graph. So we have different buildings. Best case, a building has a waste heat which can be used directly on an energy bypass on another building as a heat source with the heat pump. The electricity we need is self-generated on the rooftops of the buildings with PV or PVT, so hybrid, so thermal and electricity generating solar system. And then if it's not directly used, then it's been stored in the geothermal storage, which is a geothermal storage. We have about 500 drillings in this area, going down to about 250 meters. The system runs now since about 10 years. It's been realized in different steps, so not every building has been opened at the same time. So it was also quite dynamic and development of this area here close to Lucerne, and sometimes not so easy, because in the beginning were only residential buildings in the first steps, and then the office buildings. So the waste heat was not there in the first years, and it was quite difficult to hold the geothermal temperature on a certain level, not to cool it too much down before the waste heat of the office buildings, especially in the summertime, then regenerated the geothermal storage. Now it's quite finished. It still has 3 to 4 additional office buildings to be finalized in the next 2 years, but the system is running stable, and the efficiency and the exergy needed is quite low, with about an average COP, as I said, now by 4.5 all over for the heating. And for cooling, it's mainly free cooling, so without chillers, only by use of the geothermal storage. So the COP for cooling is about 30, so 1 kilowatt hour of electricity for 30 kilowatt hours of thermal cooling energy. Another example, which is a little bit older as a system, was one of the first realized in Switzerland, was the ETH campus in Zurich, Könckeberg. The goal was there to reduce the CO2 emissions from close to 60 kilograms per square meter and year, lower than 17 kilograms per square meter and year. And also there we did an energy grid with geothermal drillings, about 800 drillings down to 200 meters, and to collect all this geothermal heat into different centralized heat pumps, and to use it then as a heating energy for all these existing campus buildings. And the transformation of the all campus ETH has been monitored. As you see here, there were the steps since 2005 to reduce the CO2 emissions. The red dots are the indicated measured data, so we are quite better than expected on this path to zero or close to zero by the end of 2025. On the same time, there have been realized additional new buildings on this campus. So the related floor area increased in the same time we reduced the CO2 emissions. Here, I guess I will send then the presentation to Minoo TEHRANI so she can distribute also these indicated numbers, so investment costs, also what the resulting energy cost per kilowatt hour was, 12 cents in this case, and different other numbers, which I don't go into detail in this presentation, but you can read it after by yourself. And the last but not least example is a residential buildings area close to Lake of Zurich, about 5,500 residents, close to 170,000 square meters of floor area. 75% of the buildings are older than 50 years, and the heating demand was about 226 kilowatt hours per square meter and year, and the CO2 emissions close to 70 kilogram per square meter and year. What did we here do? We had also a reduction path on the CO2 side, but also on the heating side. And how did we reach this low exergy system? We integrated 2 data centers which have been in the neighborhood of this residential area. One was of Credit Suisse, about a 10 megawatt data center, and the other one is by the federal telecom company in Switzerland, Swisscom, which is about 3 megawatt. And with the waste heat of the data centers, which have been the heat source, the new heat source for decentralized heat pumps in the residential area, we could realize the CO2 emissions within these residential buildings, resort, FHF in Zurich, close to zero at the moment. So here are some impressions for this grid, this low X grid, energy grid for heating and cooling. The piping system, the main piping system, and then also the integration of the data center waste. It has been integrated by a contract with Credit Suisse and Swisscom, which is in a fortune for this area here to have this waste heat in the neighborhood. Here also some numbers. The resulting energy cost is a little bit higher than in the ETH case. It's about 16 cents per kilowatt hour. But is still quite low compared to traditional system in Switzerland, and is so far a success also related to the CO2 emissions. So that was my presentation. I come to the conclusion. I think we do not generally have an energy problem, but we have toxic substance flow problem, CO2 emissions, but also nuclear waste, etc. And the global trends of decarbonization, decentralization, and digitization create the economic framework for such sustainable solutions for the future building stock. And many decentralized structures enhance to low X performance as a standard. And I'm looking forward to have many more areas here in Switzerland, but maybe also around in Europe, to transform the existing building stock in a way that is sustainable also for the future, not only in the new construction, but especially in the existing construction. So thank you very much for your attention, and wish you a nice day, weekend in the US, and if there are questions, I'm here. Thank you.
Thank you, Dr. Altenberger. Dr. Ellie FINI is our next speaker. Dr. FINI is an associate professor at the University of Sustainable Energy, Engineering, and the Built Environment Transportation Engineering, Ira A. Fulton Schools of Engineering at Arizona State University. Dr. FINI received her PhD from the University of Illinois at Urbana-Champaign, concentrating on characterizing interfacial properties of adhesives and sealants. She has been research affiliate at MIT's Center for Materials Science and Engineering since 2011. She is currently serving as the associate editor of ASCE Journal of Materials, as well as the inventor and co-founder of a startup company, Bioadhesive Alliance, Inc. Dr. FINI has been collaborating with multiple professional and scientific societies, federal agencies, and congressional offices, mainly as an academician. She has been an invited speaker at Kavli Frontiers of Science at National Academy of Science. She also served as Program Director for the National Science Foundation. To date, she has authored or co-authored 98 research papers and published a book and a book chapter in the area of materials. Dr. FINI has been the recipient of multiple awards, including NSF Career Award, BEA STEM Innovation Award, and nomination for 2017 BioNite Entrepreneurial Excellence Award. Welcome, Dr. FINI. Please begin.
Thank you for the great introduction, Heather. Hello, everyone. Thank you for being with us today. It's a pleasure to talk to you about some of the work we have done and maybe encourage you to help us move the boundary a bit further as it comes to waste and pollution, which hurts all of us. So I'm going to start with this image, which actually my sister, who's an artist, Elva, created, which basically shows the relation between plastic and this whale running away from the ocean. It's ironic to think waste plastic and waste that we generate, we human, can actually hurt ourselves. So it's not, everything is connected. So as you see this whale is running away, you can think of what other things happening in the ocean and in the water, in the environment around us. Plastic has been on the news recently, big time. So I'm sure all of you have heard about problems associated with end-of-life plastic. So I'm going to tell you a bit about plastic, maybe just some information and some of the things that we are doing in my research group at Arizona State University. So these tiny fishes you see there, they're actually ironic, it's plastic. We made them, funny, but this tiny plastic, which can be as small as microplastics, can get anywhere that you can not even imagine, including in your water that you drink. So when you think about plastics and waste, you may think, well, we do all this recycling and I'm separating my water bottle from my food waste in a separate container, so I'm doing my job, right? Well, not completely. Only 12% of the plastic waste we generate is recycled, and the rest of them, it gets some disappeared in the environment, some around 40% end up in landfill. In January, you may have heard that China used to get our plastic waste and what we used to ship it there. They stopped getting our plastic waste, and now we're trying to somehow repurpose them here in the US. There is an urgent need to do something with waste plastic. I'm sure you guys have heard about it. And as much as innovation and invention can come up with new solutions, we need all of you to contribute to this major challenge by not just thinking about invention. It's good to invent, but I'm not asking everyone on the call become inventors. But you can still contribute to this whole ecosystem by informing, inspiring, and influencing the community at work. You are part of it actually by attending today's talk. You automatically signed up to be part of this information group. So go out after the talk and help inform others, inspire and influence what we're trying to do to save the planet as it comes to plastics. I'll tell you about plastic a bit. I'm not going to tell you too much chemistry. Don't worry, it's not going to be too much molecules and chemistry here. But one thing I want you to know as you walk out of this session is plastics are not all the same. We call them all plastic. I just put a table here to show you when you talk about plastic, it could be polyethylene tetraflate, it could be high density polyethylene, it could be low density polyethylene. And as you see the pictures here, we have like PET, HDP, and all these other animals. They are actually very different in terms of recyclability, in terms of molecular structure and all. That's true. We call all of them plastic, whether it's a water bottle or a milk container or a shampoo container, we call all of them plastic. Well, when they are different, that means when you try to recycle them, you have to deal with them differently as well. So some of the recycling procedure you may think of, when you dump that plastic water bottle in the recycle can, you think your job is done, right? Well, depending on the type of plastic you're dumping in that recycle can, it could be depolymerized at some point during recycling. It could be grinded and repurposed in some other application. Many of them, as I said, nothing happened to them and they sit in the landfill. So depending on what plastic you're talking about, the knowledge may be already there for recycling. And hurrah, that's good, right? We say, wow, awesome. The knowledge is there, so people are recycling. Well, not so much, because sometimes recycling with the current technology, it costs more than the virgin material. So yes, the knowledge in some cases of these plastics are there. We can depolymerize them to original molecules and then build another bottle later. That's true, but sometimes it costs more than the virgin material. So people may shy away from it because of economic aspects of it. And when you think about this procedure, I'm going to tell you a bit of this solution, which one of my students came up with, and it's now patented. It's patent pending, sorry. Well, we thought instead of breaking down and put all this energy in, depolymerize them to their original building block, which could actually cost energy and money to do so, we can come halfway through and use them as is, because there's already a lot of energy went to them to make them to this shape. You can see these cute, colorful plastic pieces up here on the left side of the picture. We start from there. We get mixed plastics, and then we sort of coat them with our approach. We put a mask on their face, so now they are compatible with the rest of material. The way I told you, but all these plastics are different animals. They have different compatibility with their surroundings. So you can't just dump it in a construction material, in concrete and asphalt and cement, and expect them to be compatible and like the rest of material in that matrix. So what we do here is simply we coat them and we tell them this new identity. And the way we coat it, we use biomolecules that are grafted on the surface of this plastic. So you give me a PET flakes, this colorful red and yellow and blue. I coat them with this biografting method, and now they become a different identity. And then I add them to asphalt in this case, or cement in another project, where because their identity is changed, now they feel they are compatible. They don't separate with the rest of the matrix. It's sort of manually changing the way they look and the way they behave. We're not depolymerizing them. So you see this picture in the bottom right is what we get. And here is another picture of them from this plastic colorful pieces that are in the landfill. We basically make them to the small pieces. We grind them and change their identity by coating, or the better word for it, biografting these molecules. And now we have things that can work with the rest of construction material. When you think about plastic, rubber, all these other ways, yes, one possibility is put it on the road or asphalt or concrete in your building, but you always have to think if they will work together, if they will not separate, if they're not going to cause more problem. So by changing their identity, and you can see here in the method that we are doing, you're welcome to read some of our paper on the method. I'm not going to go too detailed on how we make it, but from the one on the left, we get what is on the right. As we go through the process, the plastic breaks apart a bit and it becomes like this octopus shape, which interacts well with their surrounding. And by the way, their surface chemistry is changed, so they are now compatible with their surrounding. You may think, well, that's good. We are actually changing their behavior, and now they are not plastic anymore, so maybe they're not as problem. Well, I can tell you one good news, that when actually we started, the idea was like getting rid of plastic, right? I told you this is a big thing, so let's get rid of it. Ironically, you may hear, well, plastic are a problem because they're durable. They're not going to go away. They stay in the environment for years and years and years. Well, we thought, if they are so durable, why don't we use their durability characteristic, which is so problematic these days, into our advantage? So when we put it actually in road construction, after we compatibilize them, after we change their face and make sure it's compatible, we notice that every single plastic case we put, it reduces aging of the road. What can be better than that? We don't want all those cracks and nasty pothole on the road. So here the yellow in this case, the yellow bar, is just the asphalt you have in Massachusetts and everywhere else. The blue here is the same thing. When we put the plastic granules, which is now their face is changed, you can see the aging reduced significantly. In some cases, we got 30 to 40% reduction in aging, which means your road may get cracked later or stand longer. You may think, what happens when aging happens? Well, roads or construction material are just like human beings. You know, when you go outside in a hot, sunny summer of Arizona, you put a lot of sunscreen because you don't want your skin get aged. Look at this poor asphalt or bitumen from when it was virgin on the left and when it got aged on the right. All these cracks and the face become old and cracked and wrinkled is because of aging. What happens in chemistry side is a lot of molecules from it is gone, a lot of oxidation happened, and the portfolio of molecules in it is changed. So there are papers we publish on how the aging mechanism works in roads, much like human skin. But in a simple term is when many materials are lost. Look at the blue here and the red are typical asphalt. And when we actually put the modification in it, now we have the green. You can see the mass loss here, a simple term, right? Yet the mass loss is much, much more in your blue compared to the green, which means molecules and constituents of roads are not running away. Well, if they run away, expect aging like that, that's terrible. If they don't run away, then maybe it's good in terms of road because now you're not losing material. And by the way, you're not polluting the air. This paper recently published in Science, which showed many emissions coming from road and asphalt surface area, which includes your roof, if you're having roofing, asphalt roofing shingles, throughout its life. You have a roof for 30 years, 25 years, during its life, it's sitting out there and emitting all these molecules and contaminants to the air. And at the same time, it's getting aged. So it's sort of a double damage in a sense. It lose all these molecules. You may see all this, fancy name of benzoic acid, benzofuran, hexanol, all this. You don't need to know what they are because some of them are quite nasty and they get to the air and pollute the air. And I just showed you, well, you don't want them gone because they belong to the road, not to the air. So here you can see the road get aged and cracked and pothole as they run away, and the air become polluted. As we breathe them, we are getting them into our lung and our respiratory system. So what if we can keep the material where it belongs to and not letting them go to the air? Right now, 43% of Americans live in areas that are not healthy air. And when you think about these precursors of ozone, I just showed you those chemicals, they actually may be precursors for ozone, which is connected to asthma and lung cancer. And many of the cities, including Phoenix Metropolitan, where I'm sitting, it's one of the 10 top cities that are having ozone concern. And imagine in a summer of Arizona or your summer where you are, we are continuously emitting these nasty gases to the air and our roads get aged. So then the solution came as, what if we work like magnet and keep all those gases in the road where they belong to? So my students came up with this idea of magnet idea, of course, in a sense of grabbing the molecules that otherwise run away. And you can see here, these are the molecules that will run away if you don't do anything during their life as the asphalt get aged. And asphalt is not just the road and airport and bridge deck that you see. It's on your roof as well, and many other places that you don't even know. It has a lot of application. And this doesn't limit to asphalt. Any of the petroleum-based chemicals and products that you use, they emit this type of products to different extent. So the solution came as, well, the plastic that we started working with, it did improve the aging, but we didn't know exactly how. We dig into it further and we found out that it actually grabs all these hexagonal and the benzoic acid and all those nasty things on the plastic surface. So instead of when the plastic modified asphalt is in the road, it can keep them and trap them just like this. So it keeps them from running away. And maybe in a summer of Arizona, now we don't have all those smelly roads that they smell like petroleum as they emit. So maybe we will have in future other less asphalt that are healthy and they're trapping their volatiles. So with that, I want to tell you that this is two inventions I just showed you. They are patent pending. We think they're impactful and hopefully at some point they get out in the market. But we need more than that. The plastic problem is not just single problem we just showed you. And I already told you plastic are so diverse that you can't even call them plastic. They each have a name. It's like if I call all of us in this meeting as human. Yes, they can call us human, but I have a name. My name is Ellie. And in this case, plastics, each one have an identity. As such, they have different recycling methods. So if my group has come up with one single tiny solution here, we need all of you to start thinking and inspiring others to come up with other solutions. So I want to preach this, and I do that all the time in my group, that we need to inspire others, we need to inform others, and we need to influence the culture of invention and innovation. And this is something you can do it. Whoever you are, wherever you are, you can contribute to one of these 5 I's: inform, influence, inspire the culture of invention and innovation. Please do so and take away this message with you and help us make the change. And here is a few of the association and organization who are very active in this. Of course, Arizona State University have been #1 in innovation last 6 years in a row. So we do a lot of support for innovation in and outside of ASU. It's an open innovation platform. So if any of you anywhere you don't know how to invent or patent your technology, ASU offers an open innovation platform. You can reach out to us and get help. And there is NAI. And I encourage all of you, if you want to donate to enable the first-time inventors, go to NAI, which stands for National Academy of Inventors, and help enable an inventor out there who may need $500 or $100 or something to get started with her or his idea. So NAI actually has this funding that enables first-time inventors. American Association for Advancement of Sciences, which I'm an ambassador for, promotes invention in different ecosystems. And of course, I work with BBC Women in STEM to promote invention all across. So let's turn what stinks today into what sticks tomorrow together. And with that, I'll pass it to the next speaker.
Thank you, Dr. FINI. Our next speaker is Dr. Larry Fulton, Associate Professor at Texas State University. His doctorate is in Management Science and Information Systems. Larry has 5 other graduate degrees in various disciplines, including statistics and health administration. Dr. Fulton teaches both data science and health administration for Texas State, Northwestern, and Boston College. His research portfolio includes the application of advanced quantitative methods to sustainability and healthcare problems. One of his latest publications includes forecasting rainfall using time series with machine learning components as part of a simulation for evaluating hospital rainwater harvesting designs. He has articles associated with both healthcare and sustainability in high impact factor journals such as Sustainability. Welcome, Dr. Fulton. Please begin.
Thank you very much. I'm going to go ahead and share my screen here. Let's make sure it comes up to the right one. So with a little bit of luck, let me minimize that. You can see my screen. So I'm going to change gears a little bit. I'm going to add on to some of the other speakers by talking about a case study. One of our other speakers already said that financial considerations are a big component when talking about sustainability. When I retired from my first career way back in the day, we decided to build, and by we, I mean my family decided to build a house that would be reasonably sustainable. But as you know, Americans only do the right things after they've tried everything else. So to build something sustainable that could be promulgated across a residential area in rural areas meant that it had to be both green for the pocketbook and green for the environment. And that's what I'm going to talk to you a little bit about today, about things that worked, break-even cost, things that didn't work, etc. All right, there's our outline. This is published in Land. It's just a case study. Of course, it has simulation and break-even analysis, but is a single case study for a residential area in a semi-arid region of the country, which is Texas. So sustainable rural land use is unique because it really requires environmentally sound construction to begin with. A lot of counties anywhere in the United States will have water constraints, building constraints, etc. With Texas, we live largely off of aquifers. And so designing properly becomes a big problem in terms of water quality. We'll talk about that. The construction of residential areas, or essentially rural residential areas, you have to consider water supply in a semi-arid region of the country, electricity demands, and use of landlubber and other materials. There's a whole ecosystem that you're interacting with, and you should try to optimize that interaction. We'll talk about that. Improper land use, and this happens all the time with some of our construction companies here in the United States, accelerates global warming, has impacts on human health, leads to eutrophication or acidification of water, and can cause smog formation in the urban areas, not so much out in the rural areas. Wood products are one of the biggest land use impacts for rural areas. And the first thing I'll say is sustainable construction begins with planning it out. It is a deliberate event. All right, so I'm going to talk a lot about things we did in the building process, but there are also planning and transportation considerations, global warming potential, electricity, water, and wastewater considerations that are really the four major items in this little case study. So the purpose and research questions follow. The case study: analyze sustainable construction design for a semi-arid rural environment versus traditional construction. And when I say semi-arid, our median rainfall is about 34 inches a year here in the San Antonio region of Texas, meaning that we get 34 inches one time and 0 the rest of the time. That's typical. Now, we've had a very, very wet year, but typically the rainfall happens in bulk. Okay, we get a couple months with good rainfall and then a lot of months with sparse rainfall. So you have a variability factor. Okay, we wanted to estimate which sustainable construction options achieve break even, both green for the environment and the pocketbook. Because let's face it, we're never going to get Americans to adopt green construction unless something is incentivizing them to do so in general, or until they find out that, or they buy into climate change, right? So we have to have some incentives to make this transition quicker. And we're going to investigate the net present value for 2 separate building options, traditional and sustainable. And these are fixed options, but you could rotate things in and out. We have spreadsheets and analysis based upon different sizes of house and the like. I'm going to focus on 2 options today is all. Significance is for the pocketbook, for the environment. I'm going to give you my lived experience, what worked, and renewable resource analysis. All right, we are focused primarily on solar production for energy in this study. The reason for it is our wind speed and the transition from wind speed does not work too well in the area of Texas we're talking about. The wind speed isn't sufficient to have a return on investment. Otherwise, we would have investigated residential wind turbines as well, even though they're much less efficient than other options. So we have a 4,800 square foot home that we were building. We're going to conduct a break-even analysis, and that's going to be based upon the net present value, okay? The sum of the returns over the accumulation rate for each time period. And then we did a qualitative assessment of the triple bottom line. So just to give you an idea, construction categories and components evaluated, right? We evaluated the framing. Traditional was lumber, sustainable was engineered lumber. This is reclaimed wood. This is wood that was either cast out or that was fallen, and it was finger jointed, okay, to make lumber. We looked at insulation, traditional fiberglass or isonine foam. There's other options out there, but those are the two we're evaluating here. We looked at the fenestration, whether it was standard or Energy Star windows and doors and the like. Of course, these are the cost structures associated with this particular design, given the assumptions. And you can see that there's a little bit more for Energy Star right up front, but absolutely more bang for the buck. We looked at water, well versus rainwater harvesting, only two options. We're in the rural area where there's not a water supply. You either drill a well or you conduct rainwater harvesting, and we'll talk about that. Wastewater, anaerobic versus aerobic, water heaters, electric versus tankless, electricity grid versus solar. We even looked at vehicles, traditional combustion vehicles, battery electric vehicles powered off of solar. And we also looked at the heat pump versus geothermal, which we just had a great discussion on geothermal for large sections. We looked at geothermal using essentially wells drilled into the ground, but no cooling source, for just wells doing like a heat exchange all the way through. All right. So this is why. This is the house structure. This is a case study. I use it as a case study. I've done simulation work on it for rainwater harvesting. I've used it for analyzing the effect of battery electric vehicles. This is how we built it. Okay, starting from the beginning, we had construction recycle bins. Okay, you have to plan this out, right? But even before the construction recycle bins, you can go to the house layout. We oriented north-south. Okay, north-south because we capture more solar in this area with that north-south facing, and because of the prevailing winds for natural cooling. Construction bins to capture all the possible reclaimed items that we could. Local stone, all gathered within the 50 miles of our area, because we have granite areas out here. It's just our limestone, huge limestone areas to minimize transportation costs and the like. Engineered lumber, these are finger jointed studs built together from reclaimed wood. Isonine foam to make the, essentially to seal the environment of the house, right? You want a tight seal around that house so that it retains heating and cooling. Mini splits, this is something that I'm a big fan of, because you can turn off mini split air conditioning units or ductless air conditioning units. One are much more efficient, and you can turn them off to areas of the house you're not using. Rainwater harvesting, huge. I'm going to talk a little bit about rainwater harvesting, but not that much, because it's a whole separate presentation. In this area of the country, we live primarily on aquifers, and the amount of aquifer from water from rain that gets into the aquifer is 20% or below. With efficient systems, I can capture about 90% of the rainfall on my roof and send that to a tank, which could be above ground or below ground. Mine's above ground because I have land, and use that 100% to offset all the water requirements in a semi-arid region. Okay, so I'm using more efficiently. I'm using less because everything is Energy Star, everything's low flow, dual flush, that type thing. And that the technology's there. Simulation to determine the sizing of the system. I wrote the simulation to do that, but very, very simple. Purification process is well known. We run it through, I now have a charcoal regeneration system, and it runs into UV filtration. Energy Star throughout, you've got to do that. That's rule one. The aerobic septic system, more expensive, but better for the environment. The geothermal field, 4 loops going underground. Experimenting with tankless water heater. Bottom line up front, this Nissan Leaf, powered by a solar system, or solar generation system. A photovoltaic system, that's the way to say it. So what we wanted to know is, okay, if we do this, and I'm not going to talk about what we didn't evaluate, there's a lot. If we do this, what's the break-even cost for traditional construction versus sustainable construction? And it really depends on the mix, right? But you have to have a framework for evaluating this. So we only evaluated these items inside the house. This is not the total cash flows for each one of the houses, but we evaluated each one of these inside the house. And you can see that we have break-even starting essentially 5 years later. We reach some break-even depending on the options we choose. So let's see if I can, for whatever reason, it's not wanting to flip slides anymore. There we go. All right, so here's the bottom line. Now, let me see if I don't know why it's not flipping. There it goes. The sustainable land use and construction efforts benefit the environment and the bottom line. I mean, we reduced our impact. We attempted to be net zero in the construction. We're still changing things to try to be net zero. And some of the options we chose had a near zero break-even time. The Energy Star windows and doors may cost more upfront, but the fact that when you combine them with the isonine foam in this tight envelope around the house, the break-even is that first year and reduced energy costs and consumption. Let's see, 100% photovoltaic system, the purchase of an electric car and others saw delayed break-even points, and some sustainable efforts never saw any break-even, like the aerobic septic system, but that's necessary to frankly, it's a cost structure. Geothermal proved a bit ineffective here, even though the temperature below the surface 200 feet down is supposed to be constant. The system itself was not designed properly, okay? And there's some things that have to be done up front. And the additional cost of all the sustainable construction was about $55,000 for the option shown. And finally, let's see, I think I have a note here. Yeah, there we go. Am I not connected to the audio? Can you hear me? I have a note here.
We can hear you.
Okay, thank you, Heather. Based on reasonable assumptions, the construction of this house saved between 25 and 90 trees. We used reclaimed wood. These were already fallen or discarded stuff. Everything's finger jointed studs. The carbon dioxide avoided by leveraging solar photovoltaic systems is significant, okay? And we have some analysis on that, but not focused on that. The difference in carbon emissions is about 4.326 million grams per CO2e. The environmental effects of burning gasoline in the vehicle were reduced to near zero. I had this PVS system, the photovoltaic system, and a Nissan electric Leaf. I was an early adopter. I was literally charging my Leaf by the PVS, driving back and forth to work. I had no gas bill, I had no electric bill, I had no water bill. Okay, so the idea is in this residential construction in rural areas, it's possible to make things green for the pocketbook and green for the environment simultaneously, particularly from a policy perspective, if we require solar mandates. I mean, it's kind of a no-brainer in areas where there's a lot of sun, harvested. If we control water usage requirements in regions of the country that have water issues, which are going to get larger and larger, right? And we know that there's changes that occur all the time. And if we put additional water resource controls in Texas. I'm going to talk about that in a minute. But let me just say up front, when it rains, I'm capturing water. When the sun's out, I'm capturing electricity. I'm feeding it right back to the grid. I would store that energy because I make more than I need. That's why it goes back to the grid. But the storage solutions are not sufficiently advanced such that they're not as clean as you might think they are. So solar walls that are coming out by Tesla eventually are from lithium ion, and they decay. They lose about 50% of their juice after 10 years for storage, and they're incredibly expensive. So there's no bang for the buck there. Lead acid batteries obviously are very dirty. And so there's some other issues. Once reasonable storage becomes available, I will store the solar and just keep it and really disconnect the grid totally. Water controls in Texas, the last thing I'm going to talk about, and this one's going to shock you. They're so lax, it's not funny. Anybody can go down and suck as much water out of an aquifer as they want to do whatever with it they want. They can even drill at an angle or horizontally to get to water and drain the aquifers. That is the Texas water controls. More on that later. All right, so here's what I would like to continue working on, and that's the use of spent coffee grounds. This is kind of one of the many types of insulation they have. I think spent coffee grounds for insulation will actually improve even over the isonine foam. Prototype, I would love to have used the prototype hybrid steel and wood purlins for roof construction. Right now, I do have a galvanized metal roof. You have to consider that when you capture water off your roof. If you're using asphalt, you're killing yourself because you're getting all those hydrocarbons into your body, and not fun. So you either do ceramic or metal. Okay, there's a lot of considerations for rainwater harvesting. And then right now we can remove the Cat 7 is what we have, Cat 7 cabling in favor of wireless. Well, actually, some of it's 7, some of it's 6, some of it's 5. So you can remove that. So my whole thing is a lived experience. What can we do that's both green for the environment and for the pocketbook? Because if we don't make it green for the pocketbook, guess what? We're not going to get widespread adoption without mandating, right? And there are a lot of states where mandating smart solution sets to protect the environment doesn't go over well. So I'm more on the applied side. Ellie and Adrian had a lot of great research, but that's my presentation. I'm going to turn it over to Dr. Minoo TEHRANI.
Thank you, Dr. Fulton. Our last speaker is Dr. Minoo TEHRANI, Professor of Management and International Business at the Director of the International Programs at the Gabelli School of Business, Roger Williams University. Her PhD is from Arizona State University in Business Administration with a specialization in Strategy and International Management. Her undergraduate degree is in Petroleum Geology, and her master's degree is from the College of Engineering, Arizona State University. Dr. TEHRANI has been the program chair, president, and co-organizer of several academic conferences in Nancy, France, Montreal, Canada, Bali, Indonesia, Hong Kong, Alexandria, Virginia, and Springfield, Massachusetts. Green Cities and Sustainability, the recent conferences where she has been the co-organizer are about green cities and sustainability and include the conferences in Nancy in 2018 and Warsaw in 2019 and Augsburg, Germany in 2021. The next conference will be in Switzerland in 2022. Dr. TEHRANI is an invited member of the Swiss-US Energy Innovation Days Forum in Switzerland. In 2020, she was selected as a member of the Energy and Sustainability Committee of the town of Longmeadow, Massachusetts. Her recent publications are in the areas of green cities and sustainability practices in the restaurant industry, Dow Jones Sustainability Indices, and economic disparity and the relationship with the health of communities. Welcome, Dr. TEHRANI. Please begin.
Thank you very much for the introduction. And I'm going to share my screen. Just 1 second. Okay. I can't get rid of myself here. All right, so this one, as you know, just let's go to the next stage. The restaurant industry, I live in Massachusetts in Longmeadow, and I teach in Rhode Island. And traveling across the globe, I was very interested in restaurant industry because that's one of the most global industry. Just about every little town, village, or whatever across the globe, they have some place that people can eat. And then also they're number one in the use of energy. They're number one in waste production. But the waste that the restaurants industry they produce, they're some of the most usable waste of all time. So I came up with this survey, and I started the research in 2017 in Providence. As you know, Providence is the third largest city in the states of New England after Boston and Worcester, and also has the highest number of restaurants per capita in the US. There are streets, for example, Atwell Street, that we did most of our research. This longest street in Providence, from the beginning to the end, it's a restaurant. And then I took my strategy class, the students with me. We got a ride by our university shuttle. We all went to Providence from Bristol, Rhode Island, and we interviewed the restaurant managers or the restaurant owners. And we collected 45 surveys. And then I had a sabbatical the next semester. So I went to France, to Nancy, which we've had the exchange program with the ECM Business School for a long, long time. And then also I went around and then interviewed the restaurant managers, owners, and collected 50 samples over there. And then came down to my own town, the greater Springfield area, Longmeadow, East Longmeadow, Agawam, Chicopee, West Springfield. And also I got the help again, and of course Springfield, and I got the help of some of my students who lived around in order to collect the survey. And as you know, we ended up with 126 surveys by talking to the managers and the restaurant owners. And one of the major things that we wanted to test was, do they believe that if managers, restaurant owners and managers, if they believe sustainability will have a positive impact on their financial performance, on the reputation of the restaurant, and also attraction of customers. Because according to research, the more educated customers, the more actually they care for if the place that they visit, they are in and they are sustainable. And also, we wanted to know if they believe in sustainability, and these are the parts of sustainability for restaurant industry. Do they recycle? Do they reuse? Do they resell? Or do they donate part of their leftover byproducts? And the other thing was, we asked the restaurant owner managers if they had any training in sustainability practices. And also wanted to know, a very important point for me was, if a city is declared a green city, does it make any difference? For example, Nancy, part of the European Union, France, and Nancy particularly is a green waste city. So they have declared that the city has to do waste management. Providence, Rhode Island is a declared green state. Providence is a declared green city. They have a sustainability office in the mayor office. And then, as you know, Springfield, our area is a green energy area, but it's not necessarily at this point in time declared green city, as long as all the activities that goes on. And I wanted to know if the policies and if the laws, rules, regulations coming down from the government, the state, do they make any difference or not? So what we did, actually, the first thing that we compared is how many services per day these restaurants across these three different cities they do. And as you see, majority of them, they had 2 services. And if you look at per each city, as you see, they're pretty close to each other. So Nancy, Springfield area, and Providence, majority of the restaurants, they serve two servings, either breakfast, lunch, or lunch and dinner. And then the other thing that we studied is the type of the restaurant. Is this a fine dining sitting restaurant? Is it a fast food? Is it a coffee shop? And as you see, again, the majority of restaurants, they were fine dining and sitting restaurants. And if you look at it, what we see over here again, you realize that there are definitely, we're talking about the fine, and then in the 3 cities, they are again pretty close to each other. And then the other thing that we did was how many customers you can serve. And again, the small restaurants, we had only 10%. The rest of them, they were much bigger restaurants that we interviewed. And the capacity of the restaurants, again, as you see, very, very similar across the 3 cities to each other. So the first thing that we asked, the part of the questionnaire, sitting down with the managers and owners, was, do you believe in sustainability's impact on the performance of restaurants as far as finance, reputation, attraction of customers? And as you see, strongly agree, disagree. The blue line, you can see the blue line, strongly agree. And then the purplish, this one line here is agree. So majority of the restaurant owners, they agree that it has a positive impact on the financial performance of the restaurant, positive impact on reputation of the restaurant, and positive impact on attraction of customers. The only one in Nancy, actually, we see less attraction of the customers they thought was a point. And then we told them about the waste that the restaurants, they produce, the ones that are delivered to the restaurants, different things, cardboard, plastic bottles, glass containers, plastic bags, and the byproducts of the activities of the restaurant that included preparation of the food, meat, vegetables, leftover food, leftover customers' food, spoiled food, day-old bread, and also the cooking oil, what they did with it. So when we did the waste of the treatment of the waste, you see cardboard, glass, plastic, metal, and plastic bags. And if you look at the recycled one, the one that we see, they are more recycled than other ones where the cardboard, after that followed by the glass. But the rest of them, as you see, most of them are thrown out, the purplish one. And what Dr. FINI, Ellie was talking about plastic, that they are the most polluting ones of all the waste of any type of operations. As we see, high percentage in every city, they were thrown out. So if you look at the other way of showing this thing, as you see over here, as you see over here, the cardboard was recycled more than anything else, discarded only 24%, but the plastic bottles, the metal containers, and specifically plastic bags, majority, up to 79%, they were thrown out. Then we talked about the leftover of the operations of the restaurants, unused food of the day and day-old bread. And it was interesting that in Providence, actually, as you see, the purple one, they reuse these things more. And in Springfield, unfortunately, in our area, we throw a lot of them, the blue line, away. And the same thing in Nancy, a lot of them are thrown away. And again, if you look at these things, we realize that 43.7% of the day-old bread are thrown out, and unused of the day, food of the day, also 40% were thrown out. And then, but when we did the hypothesis, if the restaurants, managers, owners, they believe that sustainability positively impacts financial, reputation, and attraction of the customer, everybody said yes. So why aren't you doing it? And that's what we asked them after the responses that we would see per each restaurant. So why aren't you doing these things that you think about? And then we went into the directions to tell them that what you could do with the leftover of the activities of the restaurant to recycle, resell, and reuse. For example, if you look at the cardboard boxes that a lot of things are delivered to the restaurant, they can sell it. The big boxes for example, more than $1, the smaller boxes, 50 cents. And can you imagine how many boxes per each restaurant they receive the things? And as far as reusing and reselling, these beautiful bottles that used to be the wine bottles, now look what they've done to them. And we did the pricing for them, $24 per each one of these things that you can use it like a plate again. And also you can use a lot of leftover as decoration in the restaurants or other places, candle holders, flower holders, and so forth. And as you see more here again, and we price some of these things, $18 to make something like that from a wine bottle that you can hang the glasses in the restaurants. Also the candle holders. And then we talked about a very important resale byproducts of the operations of the restaurant. That was what we call coulette, and that is the crushed glass. If the glasses are separated per color, you cannot mix them if you want to sell them $50 per ton. If they are separated, they have a huge market in different areas, from paving to asphalts, you name it, they have it. And nobody that we talked about, they were aware of this. And then the other one, as you know, the use of plastic since 2017, by 2017 has increased 120 million pounds across the globe. And mostly 85% are not recycled, and they have a negative impact on 700 species, not considering the animal species and including ourselves. So what are we doing using all these plastic bottles and not reusing them or changing into some other form that actually it is much more, much safer? And here again, we showed the restaurants, managers, owners. These are the things that one could do with the aluminum, that 50 cents per pound and 2 cents per can. And what can you do with the day-old food? You can donate it. You can actually make other food from it. And a major place for reselling is the pet shops. The leftover food of the restaurants, and also animal shelters, and definitely soup kitchens. And then again, the leftover from customer waste, compost is a major part of it. We found only one restaurant in all the restaurants, 126 of them, that we interviewed, only one restaurant, they had compost barrels behind the restaurants. But again, the pet shop and plant nurseries, and definitely making compost major use. And what do you do with the trimming of leftover of trimming of vegetables and meat? You can make other foods out of it. You can make sausages from it. You can make actually pies from it. And also, again, the reselling part of it is the pet shop, animal shelters, and composting companies. And then one of the most valuable byproduct of the restaurant's operations is the cooking oil. Cooking oil not only can be used for oiling different machineries, but definitely pet shops, they have a major use of the cooking oil because they mix it with their dry food for their pet animals, and that's a major part. And what Ellie again was talking about, some of the research that she was doing, we're talking about the oil, and they can be used the restaurant oil. Now, one of the things very interesting when you compare, for example, US versus the other countries. In US, the food portions are definitely much bigger than the other countries. And when we study the developed countries versus emerging countries, most of the food actually is waste at the consumer level in developed countries versus emerging countries, that the food actually, a lot of it is waste when it's delivered from the agricultural centers, agricultural places to the market because of lack of refrigeration or proper transportation. So one of the things for reducing the leftover food of the customers is reducing the size of the plates that we have, reducing the number of selections. And in the US, we have the doggy bag rule. But again, when you go to France, nobody has said about doggy bag, or Italy for that matter. The other countries that we know of, they don't have doggy bags. But when talking to the restaurant owners and managers, and also the research in this area, restaurant industry is extremely fragmented. For example, you serve 100 customers per day. And then also there are so many of them around, and they're in continuous in transition, permanent, regular customers versus tourists, or for that matter, the customers' lack of appropriate training and so forth, and also the mix of the workers. So what do we need to do? Looking at the thing that we discovered, Nancy, a green city, part of the European Union, all kinds of rules and regulations regarding waste management. Specifically, the city of Nancy is a university city, tons of restaurants. The same thing in Providence, but it's not happening. So why? All the research, it shows that the rules and regulations, the best time, the best way to actually implement them is when the community commits to it, when the community starts implementing these things. At the country level, rules coming down, it doesn't make much of a difference according to not only this research, but a lot more research regarding this area. So we need a strategic alliances, what we call PPP, public-private partnership. We need it at the mayor's office. We need it at the community organization, chamber of commerce, and the academia around us. You heard some of the researches by my colleagues across different universities. We need the scientific community, the different community organizations, and our community. For example, in our town, Longmeadow, we have select board. In Providence, in Springfield, they have mayor's office to work with them. And then training is extremely important, because when we talk to the managers, restaurant managers, as far as training, the only training they were talking about is separating, for example, the cardboards from the rest of the things. And that's why we see more cardboard recycling than any other thing. So what we need to do, one of the questions by the restaurant managers was, how come a tiny restaurant like me to do all these things? So what we need, again, public-private partnership that creates jobs to create this type of a thing. For example, created community organization, hire some people, get a truck, and start every evening going down the restaurants. For example, in my area or in Providence, actually the entire Atwell street, restaurants after restaurants, 110 of them. So collect everything, and that's what we could do for the oil, for the culette, for the, for example, for the glass, for the cardboard, and so forth. And also something else that a lot of them, they have leftover of things. And the small businesses, if they collect, they order collectively, not only they become bigger actually customers of supply sources, they can become more cost efficient and ask for reduced prices, but definitely more efficiency along that line. So the other thing that we talked about, it was the bin design, that definitely, where are they? For example, in coffee shops that I go in my town and East Longmeadow, in Longmeadow, there is something that's a recycling. But what do you recycle there? Plastic bottles, cardboard, paper, everything. So this type of plastic, this type of recycling design, this is not appropriate. And in one of the conferences we had in Hong Kong, actually, that was one of the faculty from Hong Kong, that, as you know, that's a heavily populated area, a lot of waste, a lot of restaurants. So this is something that you make absolutely clear where what goes into where. And then the bottom line is private-public partnership, PPPs, they can create green and healthy communities, and they can create jobs. Now, a few years ago, every year, actually, I asked my students to take a photo of the leftover food after they leave the school cafeteria, because that's, you know, universities are one of the most producing of time. So, and this is the leftover food. You can probably feed 3 more, 4 more people from this food left on the table. And this is a picture of the leftover food at the end of the day from universities in the area. But what we can do with that, we can do this. So there are a lot of things that we need to go to training, and actually, and then, as I said, PPP, the partnership at the community level, and that's the name of the game. And this is the paper that we published on the rates. Professor Larry Fulton is one of my co-authors, and thank you for your attention.
Thank you, Dr. Tehrani, and thank you to all of our presenters. Before we begin our question and answer portion, I would like to welcome Andrea Chasen, Chair of the Energy and Sustainability Committee in Longmeadow, Massachusetts. Andrea?
Thank you all. This has been an incredible learning experience, and I thought I was going to be leading off, but my computer and the connection didn't necessarily work, but I appreciate the time to say thank you to all of the presenters. So as Heather said, I'm Andrea Chasen, and I have the privilege of chairing the Longmeadow Energy and Sustainability Committee, and this is one of the co-sponsors of this morning's presentation. This relatively new committee here in Longmeadow was formed to promote the work of helping the town, its residents and businesses reduce reliance on fossil fuel consumption, improve our carbon footprint, and learn how to become a more environmentally sustainable community, thereby improving our resilience in the face of a changing climate. To achieve this, outreach and education are two critical pillars. And this year, our committee will be sponsoring quarterly workshops on a number of different topics, all with the goal of giving participants the most up-to-date information about new practices and technology to become more energy sufficient and sustainable. And as a result of these presentations, I'm already seeing an outburst of new possible workshops. I also want to thank Storrs Library for hosting this with us. I'm delighted that this workshop was the first in our series. I want to express my appreciation and thanks to Professor Tehrani, who's a member of our committee, who has shared her knowledge and connections in developing this workshop. I also want to thank our panel of experts who come from near and far, Professors Altenberger, Stuckman, Fulton, and FINI. They're sharing their passion and time with us this morning, and thank you. They know that dealing with climate change and sustainability must happen at the local level, move on to the regional, and spread to the states and countries. This work must move down from the top and up from the bottom to be truly transformative and effective. So as we heard from all of these experts who are helping to transform our world by inspiring, innovating, and educating their students to be better stewards of our world, these presentations were relatively short. Hopefully they gave you an idea of what's going on in the rest of the world and that we can incorporate here. And so the last thing I want to say is that for those participants who are residents of Longmeadow, we have made available at reasonable prices rain barrels and compost bins, and I will put in the chat the contact person for purchasing those. That once again, thank you to everybody for participating. I look forward to your questions.
Thank you, Andrea. We will now begin the question and answer section of our program. If anybody would like to speak, please raise your hand virtually and you'll be called upon.
Actually, if I may interfere a little bit, I'd like to thank Andrea. Andrea was supposed to be doing the welcoming at the beginning, but she had issues with her computer and we were emailing back and forth. But what this committee is doing, which, you know, I got very interested in it and I'm on it now, they're doing fantastic thing. So, so that is, I like to thank Andrea. I like to thank all my colleagues from different universities to be with us. And also I like to thank Heather, what our beautiful library is 5 minutes from my house. Honestly, God, it looks like a mansion, that it's delightful. And all the research, this waste restaurant research that I did, I sat in this room that I'm presenting from our library now. I sat in this room and I did the research on it, but thank you very much.
Thank you, Minoo. Does anyone have any questions? You can raise your hand. Adam.
Thanks for coordinating. My one question would be, how can we ensure that creating a sustainable future cuts across political differences and political parties, specifically in local communities?
If I may interfere, I tell my students, as you know, Adam is, I'm part of my Democratic committee of my town. Adam actually is working with one of our Republican senators in Rhode Island, in Providence. So, and I have several students, actually, they are involved in the student senate. So they're practicing the, the political acumen actually at this point in time. But Adam, I don't think sustainability should be something for a dispute, as you heard, and what we're feeling now in California, all over the place. It doesn't stop at the Democrats, doesn't stop at Republican. They need to get together. And I'm hoping that, as you know, the G20 summit is going on. After that is the United Nations climate actually summit going on. And I'm hoping that everybody comes together and do it. We cannot, as I said, private-public partnership. If we don't have it, we cannot succeed.
Let me jump in here, Minoo, because I'm in a very, very dark red state, right? Where, global or climate change is often poo-pooed as an attempt to manipulate individuals out of carbon and fossil fuels over to something better. And often it's advertised as because it benefits the dark blue versus the dark red. Okay, so that's kind of the dynamic. So I get what Adam's getting at. And here's my point, Adam. The way that we get to that, in my opinion, where we cross the aisles, we can have reasonable disagreements on climate change, but the climate's changing. We can have reasonable disagreements on that, that's fine. But if we make it such that it's both green for the environment and green for the pocketbook, that means policies that incentivize the use of sustainable mechanisms, devices, whatever, processes. If we make it green for the pocketbook and green for the environment, then it will be absolutely won over on both sides, okay? I think that's the thing I've learned here. Because if you build something that is good for the environment here in Texas, but it doesn't benefit anybody's pocketbook or the individuals, it doesn't get adopted. And so wind turbines, we have whole cities that are working off wind turbines now. Why? Because it benefits both the consumer with high wind areas and it benefits companies and the like. But you do have to make it, honestly, I can't say it any better, green for the environment and the pocketbook.
Actually, I totally agree with Professor Fulton, because when we talk to the restaurant owners, managers, it's extremely important to understand recycling, reselling, donation. They definitely they enhance the profitability of the restaurants. And not only restaurants, just about every other business, because we're talking about resource efficiency, we're talking about reselling, we're talking about reusing. So whatever resources you use, the amount it comes down, and by reselling, reusing, or recycling, you can also, what Larry was talking about, green pocketbooks. So you make more profitability, including your reputation and attraction of customers.
Thank you for your question, Adam. Does anybody else? John. Go ahead, John.
I want to commend the speakers for a wonderful presentation in terms of information and content. It was very helpful and very informative. I have, for example, Minoo mentioning just having the different bins indicated clearly makes it easy for the users to dump the appropriate trash in the appropriate bin. That's a big problem I have. I can't find the right bin at times, and I look several minutes to find it. So things like that can be very useful. I had two questions for Professor Fulton and Professor FINI. And of course, I totally agree, Professor Fulton, about the economics of things. I teach finance, and as you say, without giving a financial incentive to the users, it will be hard to promote sustainability. And I really liked the way you approached your presentation, that you looked at the financial aspects of the solar used house. One question I had is, what is the ability to use reclaimed wood? I'm not familiar with this area. If there is a big expansion of housing and building, will there be a big ability to use reclaimed wood?
Thank you very much, sir. Yes, the correct answer is because we are growing, and the traditional construction industry, unfortunately, has a lot of wood waste. And what they do, I'll just be honest with you, a lot of these developers are, they're not evil, but they are allowed to strip a land, to pretty much bulldoze every piece of lumber on that property. What happens to that? I mean, it's ridiculous. I have to be honest with you. Some of our environmental policies in Texas are wrong. But yeah, there's a lot of it available. So even if in the construction, as they build these houses, even if they, did it responsibly, there are pieces of wood, typically 1 to 2 foot sections. And the good news is that they're stronger from a construction standpoint, at least vertically. They're stronger than if you were to even just get a single piece of wood. So they're essentially, they get fingers placed on them, and they get slapped in with the fingers on another piece of wood and set in place. And that's kind of the process for reclaimed wood there. But unfortunately, it's hard to sell. It's hard to sell the reclaimed wood here.
There is no market for it, or there is no good market for it.
Yeah, that's the problem. It's a lot of people, again, a lot of people don't understand that this is something that needs, I mean, it doesn't cost anymore, but it saves trees during the construction process. And if it doesn't cost, if there's no benefit, who's going to use it?
Yeah, thank you. And the question for Professor FINI I had, your presentation on the use of plastics to enhance the durability of roads is really huge. What are the financial, have you looked at the financial analysis of something like that?
This is a very good question, actually. So we did look at the environmental aspects of it, as I mentioned, in terms of emission and how we can reduce some of those. As far as the aging, there has been a lot of study already on the Federal Highway Administration and Department of Transportation across different states to show that how much it costs for repair and maintenance of the roads. So there are a lot of numbers out there. I think one challenge is the cost is not the challenge here, because the approach that we use is not depolymerizing, is actually very low cost. The main challenge here is the spec, and how would you use a material that is not traditionally known as a construction material? With most private parking lot, you can do, I guess, whatever you want, but in major infrastructure, it has to be on approved material list, and plastic momentum is not very old in that sense to have all those specs developed around it. And there is also a perception, whether from public or private, that plastic is seen as negative. It has all these environmental issues. So when you are trying to repurpose it, that negativity comes along with it. So I would think, as much as I think techno-economic analysis, it's a must for this type of innovation, I think perception and regulation are the other two big, I guess, barriers to entry.
Thank you.
Sure. Thank you for asking.
Thank you. Raheen has a question. Sorry, Raheen. Go ahead. Raheen, can you unmute?
Yes. Okay, can you hear me now?
Yes.
Okay, cool. I want to thank everyone for and all the presenters this morning for sharing. I am a new homeowner, and I noticed some of the people who own homes in my area have solar panels on top of their roofs. Now, I have solar for my flower bed in front of the house and things like that. However, I notice I still have to plug in the lighting system. So before I make that transition, is it really going to be cheaper for me if I still have to use electricity? I guess this is toward Professor Fulton, because I'm trying to, economize, and it don't look like I'll be saving if I still have to use my electricity.
It's a great point. And let's just go with your whole house, right? So if you put solar, a photovoltaic system on your house in your particular location, you have to evaluate, if you're looking economically, how many hours of expected sunlight you're going to get per day, the size of the system you put on, and then the cost of installation. In the past, when I installed my first system, it was 30% tax credit, so that reduced the cost, and I could amortize that over 7 years to get the return on investment. However, that's been reduced to 26%, and the cost of panels has gone up because of inflation. They just have. So what ends up happening is you can only offset a fraction, typically, of your house electricity use, unless you have to do the analysis, but unless your house has been designed with Energy Star all the way throughout, unless you know what your demand structure is, and in your location, because sunlight isn't the best thing to harvest there, it would take a lot of panels, I guarantee it. So if you want to try to get a zero electric bill and flap that back, it's going to take a big expense up front, and you're probably not going to reclaim that for 15 to 20 years, which the life of the panels, is beyond 20 years now. You still get about 90% production at 10 years. But bottom line up front is, is it economically appropriate for you? That's the hard thing. Now, even offsetting a bit, though, does offset some carbon production, right? So for everyone you feel like for the expense up front's big, buddy. That's it.
I've looked at it.
It's big. The expense up front is huge. And you have to figure out, okay, when does that actually give me a return on investment? It's different for everybody. And the problem is, in my opinion, is that the incentives are too low, especially when inflation increases.
Right.
So the policy procedure for me, one, would be all grids will accept every bit of electricity that solar produces from homeowners, and they will give it credit back to the individuals, because that doesn't happen everywhere. And number two, the policy should be that all new construction, just like in California, offsets 100% of its uses with the, kind of like what they do in Switzerland, 100% of its uses with the capture, with sustainable energy sources, whether that's solar or wind turbine or whatever. So, but with an old house, retrofitting, unless, I don't know what Massachusetts incentives are, I'm sure they're really good. But unless you get some really big tax credits, sir, and with the hours of sunlight you get over the seasons, right?
Yes.
Your return on investment time is likely to be 15 to 20 years.
Yeah, that's not a good investment. Okay. All right. Well, thank you. Then they have another system, and I guess that would be another question, I guess maybe at a later time, but I'll try to do it in short, if you don't mind. They have these new generators that they install into your home. So where you don't have to take a generator and plug it, outside, or not plug it, but add gas outside. They attach it to your home. So now it's intertwined into your electrical system there again. Are you familiar with that?
In fact, I have one.
Okay.
It is like Generac whole house generators with automatic transfer switches, for example, that kick in case you lose power. Because if I lose power, I lose water. I rely on myself for water. I don't have a water distribution system. So if I lose power, I lose water. So there is a carbon output to those. The best are natural gas, closely followed by propane, because they have the smaller of the two footprint. You do not want from an environmental perspective, you definitely don't want a regular gas burning generator.
Right.
So they can be very efficient, particularly if you have natural gas. And a lot of places in Massachusetts do have natural gas pumped in. So that makes it really easy to work with, right? And the environmental offset isn't bad. So should you use power as a backup, that works pretty well.
Okay. Thank you very much.
More than welcome.
I like to mention something that I just got to know about this. When, for example, in Europe, every grocery store, there is I think we have one in East Longmeadow. We don't have any in Longmeadow. There is a recycling for glass and for that matter, and whatever else. And then you get 2 cents, so you get some money back, and that's a major incentive. Recently in Enfield, they have several of them. I think we have only one in East Longmeadow that I know of, nothing in Longmeadow next to the grocery stores. But something very interesting, if you look at different, for example, plastic bottles or glass bottles, at the bottom of it, it tells you where you can recycle it. Actually, go put it there and get 2 cents or whatever, because that's a major incentive. What Larry was talking about, something green in the pocket. So that makes it more actually incentive for the people. But then it says on where you can do such a thing. For example, those Poland Spring, those big bottles of water, you can only recycle it like that in California. A lot of things that we buy from our grocery store, Sierra Rock in Longmeadow, you have to recycle them, for example, in Connecticut or Maryland. And I don't know why. So maybe that's something that our policymakers, they need to take a look at and see why, for example, these bottles, they have to be only recycled in California. Why these bottles, they have only to be recycled in Maryland or Connecticut or wherever. And it was an eye-opening experience for me, because I didn't know that we cannot recycle, even though we go to a recycling redeemable type of a place. You can still not recycle just about everything. It was very surprising to me.
Thank you, Raheen, Dr. Fulton, and Minoo. Does anybody else have any questions? Raheen, go ahead.
I know, I can go on a bit. But I wanted to add on to Professor Minoo's statement. I can remember in the early 80s, late 70s, in the South, we used to come from New York to Florida to visit my grandparents. And for money, we would collect bottles. And the Sprite bottles and Pepsi bottles used to be 10 cents a bottle. And you would take them to the 7-Eleven, and they will count the bottles and they will give you cash in return. Now, what I'm saying is, can we bring this system back to where it's not like, as Professor Minoo said, to where it's only in a few states, but every state? Yeah. And I think it would get everyone involved, even the children, because at that time, myself, I was like 6, 7 years old with a shopping cart full of bottles, pushing to the 7-Eleven so I can get money for my candy and the likes. So I think this would be something good to bring back and institute this system where it gets everyone involved and they get a little, return on their time.
Very true, Rahim. I totally agree. I was so surprised seeing that even you go to, recycling center, you still cannot recycle these big bottles, glass, plastic, you name it, because you're not in California. They only can be redeemed in California. They only can be redeemed, as I said, in Maryland. it was really surprising to me. So maybe our committee can work on working with Big Y or something else to do something about it.
And what's interesting on that one is that sometimes people will advertise and you pay extra for recycling service and they take your stuff to the dump.
That's very true too.
Okay, if nobody has any further questions, I would like to again thank Ms. Chasen, Professor Altenberger, Dr. AZARI, Dr. FINI, Dr. Fulton, and Dr. TEHRANI. Thank you to everyone who has joined us today. And if there are no more questions, this concludes our program. Anyone else?
Heather, thank you very much. Thank you, Andrea. Thank you very much for chairing this committee. Thank you. And thank you, my
everyone.
colleagues, my friends. Thank
Have a
you.
wonderful weekend.
Bye.
Bye-bye.
Bye.